Forest, ramp, pass. Your opponent untaps with 1 land and 0 permanents in play. You untap and cast Writhing Chrysalis. You are not playing fair anymore. You are a full turn ahead on mana, and you are going to stay there. This is Gruul Monsters. The premise is simple: cheat on mana, deploy early threats, and never let your opponent catch up. But here's the real question: is this a strategy or a gamble? How often do you actually execute? We are going to answer all of that with mathematics. Let's break down the numbers behind breaking the curve. We divide the analysis into 5 parts. After introducing the deck and explaining the mathematical framework behind card draws, we'll present 2 key sequences for a turn to threat, whether it's Drad's Repurposer, Jewel Thief, or the infamous Writhing Chrysalis. Then, we'll compare them side by side and draw some practical conclusions about how to actually play the deck. Gruul Monsters is a ramp-based deck strategy in Pauper. The game plan is to deploy acceleration on turn 1, then leverage it immediately to cast threats ahead of curve. We are working with a competitive reference list. You can see the full breakdown on the screen. The key numbers: 4 copies each of our relevant pieces, 14 forests, 2 mountains, and the rest is interaction or irrelevant for our case study. We are analyzing 2 specific sequences. Sequence 1 is the classic: turn 1 forest plus any ramp piece, turn 2 second land plus Repurposer or Thief. Simple, repeatable, that's what the deck does. Sequence 2 is the fireworks: turn 2 forest plus Arbor Elf, turn 2 second forest, Utopia Sprawl, naming red, untap the elf, and tap again, turn 2 Writhing Chrysalis. These require far specific cards, aligning perfectly. It's rare, but also devastating. Every probability gets computed under 3 observation windows: your opening 7 card hand, being on the play with 8 cards total, and being on the draw with 9. More draw steps mean more chances to complete a partial hand. Keep that in mind. All our calculations use the hypergeometric distribution. That's just a formal way of saying that we are sampling cards without replacement from a 60-card deck. Here's the idea: you partition the deck into categories that matter for a specific sequence. For sequence 1, all 3 ramp spells work equally on turn 1, so they are one category. For sequence 2, Arbor Elf and Utopia Sprawl play different roles, so they are separate categories. Then you calculate how many 7-card hands contain at least one of these, at least one of that, and so on. The formula sums over all valid combinations, weight each by its probability, and gives you the answer. The key principle is simple: only track what's functionally different. Everything else is noise. For sequence 1, we divide the deck into 5 categories: forests, mountains, ramp, that's Arbor Elf and the enchantments together, 3 drops, and everything else. You can see the full partition on the screen. What do we need? Turn 1 group, forest plus ramp. Turn 2 group, a second land plus a 3 drop. Now, how often does this happen? We break it into 6 mutually exclusive scenarios, based on which cards arrive when. Scenario A: your opening hand has everything: at least 1 forest, at least 1 ramp spell, at least 2 lands total, and at least 1 3 drop. All the pieces are there from the start. Sequence B: your turn on group is complete, but you're missing exactly 1 turn to card, either the second land or the 3 drop. That card arrives at the turn to draw step. This applies both on the play and on the draw. The remaining scenarios, C through F, only exist on the draw. They capture various combinations of missing turn 1 cards that get drawn at turn 1, or multiple missing cards arriving across both draw steps. Let's walk through the calculations for scenario A. As an example, we need at least 1 forest, at least 1 ramp, at least 2 lands total, and at least 1 3 drop. We sum over all valid combinations of these constraints. That's the multivariate hypergeometric formula you see on screen. Each combination gets weighted by the number of distinct hands that satisfy it. When you evaluate the sum, you get 26%, approximately 1 in 4 opening hands. Now, with similar calculations distinguished by each scenario, you obtain these partial probabilities. They sum up to 26% for the opening hand, just scenario A. On the play, scenario B contributes an additional 7%, bringing the total to 34%, that's 1 in 3. And on the draw, scenarios C through F add another 10%, for a total of 44%, nearly 1 in 2. The stacked bar chart shows this visually. The blue segment is scenario A, constant across all 3 windows. The orange segment is scenario B, present on the play and on the draw. Then you see the additional colors, stacking on top for the on the draw only scenarios. The total high tells the story. This is your consistency baseline. This is what Gruul Monsters does. For the second sequence, the partition changes. Arbor Elf and Utopia's Sprawl now play distinct, non-interchangeable roles, so they're tracked separately, 4 copies each. Forests, Arbor Elf, Utopia's Sprawl, Writhing Chrysalis, and everything else. Turn 1 group, Forest plus Arbor Elf. Turn 2 group, second Forest, Utopia's Sprawl, and Writhing Chrysalis. 5 specific cards. Same 6 scenario structure, but now the 3 cards turn 2 group generate multiple subcases. Scenario A, hand complete, all 5 cards in the opening 7. Scenario B, turn 1 group complete, missing exactly 1 turn 2 card, either the second Forest, Utopia's Sprawl, or Writhing Chrysalis. 3 distinct subcases. The missing card arrives at turn 2. Scenarios C through F are on the draw only. They cover missing Arbor Elf at turn 1 or various combinations of missing multiple pieces. Let's walk through scenario B1 as an example. Turn 1 complete, missing the second Forest. The opening hand has exactly 1 Forest, at least 1 Arbor Elf, at least 1 Utopia Sprawl, and at least 1 Writhing Chrysalis. 13 Forests remain in the 53-card residual deck. On the play, the probability of drawing 1 at turn 2 is 13 out of 53. You multiply the hand probability by that draw factor. On the draw it's similar. With the same approach applied to all scenarios, you get the partial probabilities shown in the table. Opening hand, 1%, 1 in 75. On the play, the 3B subcases contribute 1% total, bringing you to 2%, 1 in 40. On the draw, the C through F scenarios add another 2% for a total of 4%, 1 in 23. The stacked bar chart mirrors the structure of sequence 1, just scaled down. Same color scheme, same scenario progression, but notice the scale on the y-axis. We are in single digits here. Even on the draw, this is still under 5%. Let's put them side by side. Sequence 1, 26% opening hand, 34% on the play, 44% on the draw. Sequence 2, 1% opening hand, 2% on the play, 4% on the draw. 2 completely different scales, 2 completely different roles. Sequence 1 is the deck's identity. It happens nearly in half of the games on the draw. This is what you're trying to do. Sequence 2 is the upside. Rare, but devastating. When it shows up, you seize it, but you don't mulligan for it. The line chart on the screen shows the divergence clearly. Here is what the math tells us. Sequence 1 is the deck. 1 in 4 opening hands become 1 in 2 on the draw. The 12-copy ramp density makes this possible. If you start cutting ramp for more threats, the number collapses. Sequence 2 is a bonus. 1 in 23 on the draw, never mulligan specifically for it. Recognize it when it happens and execute. Being on the draw pushes the number higher. Conventional wisdom says aggressive decks want to be on the play, but Gruul Monsters is a ramp deck. That extra turn 1 draw adds 10 points to one of your primary game plans. Mulligan decisions should be centered on sequence 1. If you have a forest plus ramp, but you are missing your turn 2 pieces, ask yourself, how many draw steps do I have? The numbers don't lie. When you shuffle up and draw your opening 7, these probabilities govern what you see. Make your decisions based on math, not on hope. That's not a gamble, that's a game plan.